reminded from last class, so we're given the slope, right, and a point that the line passes through. What does the line passing through a point really means? It means that point is part of that line, right? That point makes up that line. So that means the x and y coordinates fit in. So last class we said if there was a slope, take that slope, put in y equals mx plus b. Well, we know that m is means for what? Slope. Our part was calculated for b. Well, if the line passes through that point, and that point is part of that line, we substitute an x coordinate for x, y coordinate for y, and then we can solve for b. So as the extension to that question, here I'm giving you 2 points. Not giving you the slope, but what can we do? 2 points though. Colin who's all excited.
You can use both of the points to find the slope by y2 minus y1 over x2 minus x1.
So we can figure out the slope of this line. So that's m is equal to, so before we get to that, slope again was rise over run, which is the same thing as, so I gotta say this because I love saying it, I don't know why, delta y, which you sound cool I think, over delta x, right? Just say it, like you just walk around your friends and delta this and delta this, like, whoa, at least you know what you're talking about, you're smart. Delta y over delta x, which is the same as you guys are just saying, y2 minus y1, that means change in y, remember that's what delta means, change in y, over change in x, so x2 minus x1. So what's x2 and x1, y2 and y1? Yeah.
x1 is negative 20, x2 is 12, y2 is negative 54, and y1 is 107.
Sure, maybe. Does it have to be that? No, right? So when you get a question like this, I do this, it helps to do this, just label 1 is 0.1, 1 is 0.2. So here I'm going to say this is 0.1, just write it on your sheet, right, as you have the question. This is 0.1, so here it's going to be x1, y1. So it has to be clearly labeled, because the order of this is important. You can't get that confused. You get that confused, you get the question wrong. Here, we'll say this is 0.2. So this is x2, y2. Now we go in and plug in. So here y2 is minus 54. Y1 is minus 100, is 106. X2 is 12 minus negative 20. I can't remember if that's the order you said, Matt. Point is that here, when you remember calculating the slope, we give 2 points. It doesn't matter the order. You just have to keep your x2s and y2 consistent. Your x1, y1. They have to be consistent. So I think I was walking around. A lot of you guys did it in a different order, but you'll see we'll get the same answer. So negative 54 minus 106 is minus 160. 12 minus negative 20 becomes a positive. So we get 32. And if I did my math right, this is equal to negative 5. So now we know the slope is negative 5. M is equal to negative 5. So because we want the equation, this is the answer. Well, we just start off with, always start off with just the general form of what we're looking for. Y equals mx plus b. So here y is negative, m is negative 5. So now we got back to yesterday's lesson. Y is equal to negative 5x plus b. How are we going to get b though?
Oh,
How do you get b? Well, I split, but I got x and y there.
Just take them out.
Let's just take them out. Holy math was that easy. Right? How do I solve for b now? Abby?
You replace the x and y with the x, y value of the one of the
Well, which one? I'm giving it 2 now.
doesn't matter.
Why doesn't it matter? It should matter.
They're all the same.
Yeah, both on the same line. In other words, both of these points would make our equation true. Now it's like, you know how you go to a restaurant, you're given too many choices. Hey, you go to a restaurant, too many choices, like I don't know which one to choose. Sometimes there's just one thing on the menu, so that's why I just know what to order. Here you have a choice now. And either one of these, stop holding hands, please. Either one of these would work. Okay? So how many use the first point? Raise your hand. Yeah, so use the second point then. Use the second one. How many use the second one? Oh, so a couple did. Can we, is there one point better than the other percent?
Yeah, two has smaller.
Right. Yeah. Pick a point that might be easier. Like I might give you 2 points. One has fractions and one doesn't. So you're probably going to choose the one that doesn't have fractions. But this one, both of them have negatives in there. If one had only negatives, one only had positives, I would probably choose the only one that had positives because I like working with positive numbers. So even though you have choices, sometimes you can make a better choice. So like what Andrew is saying, I'm going to use the one with the smaller number. So here y is negative 54, and x is 12. Right? So in other words, when x is equal to 12, my result will be negative 54. So that's what we plug that in. Then we get negative 54 is equal to negative 60 plus b. So you're going to add 60 to both sides. So b is equal to 6. Thank you. You need to answer the question at the very end. It's a shame you do all this work. Question might be out of 3 marks. Do all this work, and you get 2 out of 3. Only because you did put the pieces back together and answer the question. Okay? So therefore, the equation is y is equal to negative 5x plus 6. Okay? So now that we have this answer, you can just do a really quick check by using the other point. So here I'm going to do my quick check over here. So y is equal to minus 5x plus 6. Now I'm going to use the other point. Well, what's my x value here? Negative 20. Right? So using the other point, well, x is negative 20 plus 6. So let's figure out what y is. Well, negative 5 times negative 20 gives me positive 100 plus 6. Y is equal to 106. In other words, when x is 6, y is 106. Sorry, when x is negative 20, y is 106. That matches our point here. Right? So this is good. Chances are we got an equation right then. Okay? So that's the nice thing about the second point too. It gives you a quick way that you can actually check your results. Any questions on this? See, not that bad, right, Dylan? So that's that's the nice thing about math. That's to me, that's what I love about math is. It may seem hard, but once we start understanding concepts, start putting them together, start practicing them, it's actually not so bad. So let's save you guys some writing for this class. Just one sheet worth. One sheet out of 8, not so bad. You're welcome. Okay, this class, you guys won't understand what I'm talking about at the beginning. After I taught this class the parallel lines, I changed it up to teach my other class parallel lines. So what I did was, what I did last class, or the other class was, I set up an example where cause is cool gym. They were having a promotion, right? So sign up for $40. So this is cause is cool gym. Sign up for $40 and for $20 a month, you get access to this membership.
It's 15 a month.
No. This is the original question, which you guys never saw, so that's why I'm kind of doing it right now. Morgan's Muscular Gym, though, they were running a promotion
Morgan's most.
where, you know what? You only ask for $20 up front. $20 to become a member, and then you just have to pay $20 a month afterwards. So here, what I demonstrated, so basically you had two equations here where C is equal to cost, right? And M is the number of months. So our equation for Cause's Cool Gym was, well, the cost is really $20 times the number of months that I go, plus your initial startup cost of $20, your membership fee. Whereas Morgan's
What's 40 is 40?
is,
The other way around.
oh sorry, Cause's was 40, yes. Morgan's was 20M plus 20. So I graphed this, I got two parallel lines. So that's how I introduced parallel lines here. Because the slope in these two equations are the same, right? The slope matched our rate, which was $20 a month. So no matter how many months I went, I never got a better deal. Like Cause was always expensive, right? So that's why I said here, well, thanks to my math class, Mr. Dan was really ticked at me. Nobody signed up for his gym because all of a sudden you guys became educated, became a wise consumer. And says, well, I'm going to go to Morgan's gym. So we talked, and he says, well, he's changed his plan, right? So he's still he still wants that $40 up front, but he's only going to charge $15 a month. Okay. Morgan, he was happy. Mr. Morgan, he was happy. Kids were coming in, putting in $120, $20 every month, he'd roll in the dough. So he said, you know what, it's all good, I'm gonna keep it the same. So now that Cause's Gym has changed their plan a bit, which one is the better deal now?
Causes it in the long run. But if you go in for like a year,
Yeah, so it's
A year, 12 months?
For a year membership.
So again, this is discussion as well, now it's no longer straightforward, right? Before there's a clear-cut answer, now it's not so forward because we have different plans. So what I want to do is, I want to come up with an equation that models Cause's Cool Gym. So in the past, we had Cause's Cool Gym used to be that one. So what is an equation that models his new plan? So what's our equation that we come up with now to map the membership costs or the gym costs of going to Cause's Cool Gym? What would that equation look like now? What would that equation look like now? So before, it used to look like over here, C equals 20M plus 40. What would it look like now? Michael?
Was 15 plus 40.
Yeah, so the cost is now $15 times the number of months plus our initial cost of $40. So what I want you to do in your graph now is graph the two equations for me. Draw the two lines. One to map Morgan's original equation, C equal to 20M plus 20, and do one for Cause's new equation now.
How many months are there already?
Who knows? Doesn't matter. We're drawing a linear equation. So it could be a billion months. So make sure you use a straight edge to draw your lines. Okay, you know where to start. We're going to try graphing this. Well, what's our y-intercept in this? So just graph 0, 20, right? That's the first point. And then we can use the slope after that to get the next points. Okay? So I'm going to do it up here while you guys are doing it on yours. So I'm going to do more again in blue. And I'll do cos in red. So there's 40. And I'll make 30. I can't see my lines anymore. It's there. So the other ruler should be there. Needs a ruler. The usual suspects. Please return these by 10 o'clock. So it's a little bit tougher to plot the second one, causes school gym, because the scales were a little bit off. They counted by 20s. And obviously what causes school gym is the slope there was 15. So you have to guess. What I did was I went by 2s, 2 over, and then up 30, which was the halfway point of each one. So I was no way that you could do it. Okay, so it seems like most people got lines similar to what I got. So now I want to look at this. Look at the ones that you have. So let's answer these questions together. What is the point of intersection? And where is it on the graph that these two lines cross or meet? So look at your graphs. Can you kind of pinpoint where they're crossing or where they're meeting? Veronica? At 4, 100? Okay, does everybody sort of have that on their graph? Instead of crossing at 4,
I messed
100?
up my graph.
I had
Really
5,
bad.
120.
Well, assuming that you didn't mess up your graph.
I have like 4 and I like 4.6 and like 115.
Yeah, so I graph 5, 120. Yeah.
So you're off here, because up here it should be 15, which gives you about right down here. And then go to another 15, which should give you right there.
It's a hard thing to graph.
Well, I know, that's why I went by 30s. I go across by 30. So 4, 100, what does that mean though, in terms of coordinates? What does it 4 mean? So it's 4 months. right? Because 4 was our horizontal axis in that month. And what's the 100? So the $100 cost, right? Because the vertical axis was cost. Okay? So now here's the important question of this lesson. At your point of intersection, what is it that you notice? What is it that you see or notice at your point of intersection? Yes, the lines cross, they meet. That's what I'm looking for. Conceptually, at that point, what is it that we see? What is it that we know? What does it see? What is it that we know? I want everybody to think about this for a second. It's a very important question. Some of us don't have the graphic. Let's go back. Get in line. So this point here, which we said was 4, 100. What is it that we see? What is it that we know? Andrew.
Instead of KG goes lower price than G.
Oh, okay. So notice at one point it was one was higher, but then after that point the other one was lower in terms of cost. Very good. So that sort of answers that first question of what depends, right? What else do we notice? Veronica.
At that month, they both pay the same amount.
So at that month, 4, they both cost the same. So what are we really saying? You're so close. Sorry? Their points are even. Actually, no, Veronica almost nailed it. Like, I just want to. I'm not sure we really understood what Veronica was saying. Can you say that again?
At the 4th month, they're both paying the same.
So at the 4, they're both paying the same amount. Just want to harden that a little bit more. We should understand the concept here. Aaron?
This might be wrong, but like since the KKG is paying $5 less, you made up for the $20 you paid for extra.
Okay.
'Cause, like,
Yeah. So it's sort of where you're catching up there in terms of, I think that's what you're trying to say, right? But it's just, no, that point there. I mean, it's so obvious, so too, but it's a very important point to understand. No pun intended.
Oh.
Tyler? Point of change. Well, we refer to it as a business, the break-even point, right? So we can say that it's a break-even point, but there's some this break-even point. Okay, just how about in general though? Just where 2 lines cross. In general, what is it we know about that? Right there at that point. Veronica, you try to connect that? So close.
That company doesn't reason.
Well, we don't. Like at that point, it doesn't matter for us, right? So let me spell it out for you. It's really close to what Veronica said. At that point of intersection, the value on X and Y, say, or C and the value for M is the same. For both equations. Okay? So only at that point where the C and the M is the same, or we could do it in general, X and Y. Only at that point. Like if we go back and look at our graph, if we look a point over here on this line, does that intersect? Is that those values? Can you find those values on the other line? No, because the line doesn't cross through there. It's only through here that we have a common C and a common M. In other words, common X and common Y. Okay? That is so valuable to know. And what we're talking about here is, oh, I shouldn't want to do that. I'm going to do it one step at a time. Okay? So here are the key points that we want to get through this lesson. One, stress already. The point where two or more lines cross, it's called the point of intersection. So write that down. The point where two or more lines cross is called the point of intersection. This should be folded. This is new to you guys. A linear system. A linear system is two or more linear equations. Two or more linear equations considered or examined together. Finally, the solution. So we're talking about solution now. So before we talk about solution to an equation, now we're talking about a solution, a new term called roots as well. Roots, R-O-T-S, of the linear system is the point at which the graphs intersect. That is the point of intersection. The solution or roots of a linear system is the point at which the graphs intersect. The coordinates of a solution must satisfy both equations. That is, make both equations true. Okay, so you guys are kind of seeing this. So now we know what the break-even point, 4, 20, what does that really mean in our equation, in our example? 4, 100. Let's sort of verbalize what that means in our example with Morgan's muscular gym and causes cool gym. What does that really mean, that 4, 100? What does that imply for us? It's a solution, but what does that mean in a more general term, or some more specific terms in this example? What does that conceptually mean to us in this example? I think some of you already said it already. I want to re-emphasize that point. Colin.
It's the point at which the cost is the same, and it doesn't matter which one.
Yeah. So at that point, the cost is the same. It doesn't matter, right? So after 4 months, I'm paying $100 at Causes Cool Gym. After 4 months, I'm paying $100 at Morgan's Muscular Gym. Doesn't matter which one. So if I was to go to the gym for only 3 months, which one would I go to then? Morgan. Because we see in our graph or lines, that was the line that was lower. If I was going for like 8 months, what we're gonna go to causes. So now it sort of depends. I want to emphasize this point a little bit about satisfying both equations. So we had one was Morgan's was C is equal to 20m plus 20. Well, that point must make this equation true. So how can I check that? Left side, right side? Well, the cost is 100. The months is 4. So I got 80 plus 20, which is 100. So 4 comma 100 does make this equation true. What about cos equal G? That equation was C is equal to 15m plus 40. So we'll do the same thing, left-hand side, right-hand side. So cost was 100, right? Months was 4. And we see that 60 plus 40, that's give us 100. So that's what we mean, that point, that value, that pair of values must make both equations true. No other point does that. No other combinations of C's and M's will satisfy both of those equations, will make that equation true. Only that one point. Okay. Any questions on this? It has huge application points, values as we see. This is one example. So I'm going to show you something that's really cool. Really grade 10 stuff. You do more of this in grade 10. Grade 9, the only thing you're responsible is can you just graph your two lines, see where it intersects, and give me that coordinates. Here you have our two equations. Who could tell me, just by looking at this, observation, powers of observation, what do we see that's similar, a pattern there? What can we see? What can we kind of pick up there? So look at me, look at the equations. What do we notice? What do we notice?
Does it have to be similar for both?
Similar, yeah. Michael?
The y-intercepts are both equal by 20.
Okay, the y-intercepts are different. One's 20, one's 40. I'm looking for a commonality there. What do we see that's sort of like the same? All of them.
They both have a base cost and then stuff you're gonna have to pay over like a while.
So they have a base what?
They have a base like that you have to. Well, if we're looking at it by like if we know what we're talking about like with the gyms, we can notice that there's a base cost that you have to pay, and then what you have to pay per month.
Okay, so it's sort of like the initial value, 40, 20. Okay, you have different rates. Do you have something else, Abby?
The equations are like the same format.
Okay, well, these are the same format, right? C is equal to something m plus, so y equals mx plus b format. Something more, just more staring us in the face, more obvious than that. Veronica?
The slope and the y-intercept.
Good, they're both positive. There's just something that's even more obvious than that, like just looking at it.
Is it easy obvious?
It's easy obvious.
They both have two variables.
But they both have two variables, both the same variables, and talking about something that's even more obvious.
Both equations.
So both equations,
How obvious do you mean on a scale of 1 to hard?
0. Like you're gonna be kicking yourself this. You go,
For both
of course, Mr. Tam. Like, why are you even asking me that? It's so obvious. Like,
both multiples of
you're
five
insulting me.
and
No.
They're both lines.
They're both linear equations.
They're both addition.
They're both addition.
Both
They're
y.
close.
They both have equal signs.
Well, you're getting close. They both have equal signs.
Both are equal to C.
cost.
Thank you.
Both equals cost.
I didn't hear. Okay, I didn't hear that then.
Says twice.
Right? Both equations C is equal to something. Right? Just like you're just staring us in the face. C is equal to something. So, if C is equal to this, and C is also equal to this, well then we could say that 20m plus 20 is equal to 50m plus 40.
That was like a 0 from 1 to 10.
Yeah.
Oh,
Does
like
a 0.
3.
So if c is equal to one thing, c is equal to another thing, so c is equal to this, c is equal to that, this must equal that then. Right? Does everybody see the logic behind that?
Yeah.
Okay? So now we can just plot mathematically. How many variables do I have now? 1. So we're going back to 2 units ago, right? Solving for one variable in an equation. Well, here I'm gonna subtract 15m from both sides, and then subtract 20 from both sides. So I'm left with 15m, and I'm left with 40 minus 20. And here I'm left with 5m is equal to 20. One isolate for m, so I need to divide by 5. And it's equal
Which
to.
is how many months in the.
Oh, that's their breaking
That's how much
point.
months.
Whoa! We saw that m was equal to 4 before, when we saw the point of interceptions.
Yeah.
Well, point of interception is equal to slope.
No?
M's not slow.
The slope?
I lie. Because m, I see m.
It's months.
Oh yeah, m here doesn't mean slope, m is just a variable. Okay? So now that we know that m is equal to 4, and these two equations are true because c is the same, now plug in m back into any of these equations. So I'm going to plug it back into the first one. So I get c is equal to 20m plus 20. So c is equal to 20 times 4 plus 20. So c is equal to 80 plus 20. C is equal to 100. If I'm going to try the other equation, 15 times 4 is 60 plus 40, I would still got 100. So I can plug in either one of them to get my c value. So this is how we sort of do it algebraically, right? Which comes in handy, and I just taught you the first lesson in your grade 10 course, which is just this. Okay?
That's grade 10 math.
That's pretty nice.
That's pretty easy for grade 10.
So comment.
It's easier than
And you know what? One thing I want you to start appreciating is for the math, what you know now, one little tweak is a whole new concept. That warm-up question I did for you guys, that was one lesson in the textbook. One entire lesson that you just got in 5 minutes because you know what? I just have to connect the 2 points to give me a slope. Well, now I can go back to all everything else that I learned before and do this.
Wait, we already knew that 2 points gave us a slope.
I know, but it's again tying the pieces together that is the difficult part. Yes, Abby.
So cute.
Yeah. So let's go to a practical example. I want you guys to try this. Take graph paper. So you don't have graph paper. Who doesn't have graph paper? Who wants more graph paper? You're gonna do a lot of these, so use the small one. The big one.
Yeah, these are just.
Yeah, but they're good deals.
Yeah. Good. I'll give her
At least it's double sided.
Yes, I'm good that way. I try to double side all my stuff. You need some? No? Take one more, sure, take one more. Take a couple more. Mini binder. So you want to solve the following linear system by graphing. So really this comes down to exercise, can you graph 2 lines on the same grid? Good, right?
Yeah.
Maybe that's why I couldn't see the grid before.
We have to graph it on the same graph.
So how else can you see where they intersect?
No, you go.
So fun.
We have to switch these into y equals
Snake.
Okay, what does that mean, snake? Somebody tell me. This isn't the only class I heard, and I heard other classes. Like,
This
It means like you stopped someone from doing something.
Not
Well, like it just means
It's like
you know what I
troll.
mean. It's like troll.
yeah, it's like
It's
troll.
like troll.
It's
When
getting cruel.
when someone lies to you, kind
when someone lies to you.
Not even
When
like
someone doesn't help you out.
when someone does something that you don't like. There's
Yeah.
Oh, you can't handle the truth. You know, basically, you
Okay.
can't handle the truth.
It's like
So it's biblically related to serpent.
I guess.
Serpent.
So I don't know why you guys are saying this class.
Or if someone
Am I misleading you?
If someone snakes you, they like scam you.
Yeah, they didn't
I
use
I said grab it. It's a snake. It's like what? Just grab it. What's that got to do with me?
No, because you
Okay,
didn't tell,
let's ask.
no, because you didn't tell us if we had to switch it to y.
Graph. I just told you to graph it.
Just remember what to do.
I don't know.
I totally forgot.
Graph it.
No. I actually
My life is hard for me right now.
At least you can erase that. You can erase something like.
I am.
But we all make mistakes in life, right?
I'll do
So I see everybody going off graphing.
Do I really have to write all this out?
Show your work.
This is
Well, you do it on another piece of paper. So I see, yeah, some people are, a lot of people are taking the same approach to graphing this. I see we have read for our lesson 12. Now I'm prepared to hear another snake comment. So yes, one way we could graph this is yes, I didn't give it to y equals mx plus b form, which is again our favorite form of equation of a line. It tells the slope, point. So what a lot of you guys are doing is you convert it to y equals mx plus b, graph my y-intercept, do your slope. The other way that we learned to graph was through the intercepts. So looking at this, my y-intercept, in other words, when x equals 0, I have minus y. Minus 6 is equal to 0. So y is equal to negative 6. Down here, the x-intercept, that means y is equal to 0.
Instead of -6,
Y is a negative 6, it's negative y minus 6.
Oh, I have to change the.
Didn't you just note that was -6?
Wait, could you go negative y minus 6 plus 6 equals 6 on the other side, y equals 6. Negative y equals 6.
However you want to isolate for y,
y equals 6.
I just brought y, I just added y to both sides and got y is equal to negative 6. Here, if y is equal to 0, 3x minus 6 is equal to 0, so 3x is equal to 6, x is equal to 2. Over here, and then just draw my lines for both of those points. Careful?
Alright, sure.
No worries. And then for my other line, I'll do the same thing. So So the y-intercept, x equals 0. So I get minus 2y minus 4 is equal to 0. So minus 2y is equal to 4. Y is equal to negative 2.
Fast.
So y is negative 2 over there. X-intercept, and y is equal to 0. So you get 4x minus 4 is equal to 0. 4x is equal to 4. That means x equals 1. Right there. Draw my lines.
Wait, I thought we were trying to find points.
Yeah.
It's on the graph. I was like, just look it up. I'll plug it up.
What? That's not right. No, I got it wrong.
So the line looks something like that.
I got it. It looks kind of like that.
Yeah,
Okay.
yeah, I just got 2.46.
You're losing it.
Okay, so that's why it's very important to, as accurate as you can, plot your points, draw straight lines. Else you can't tell exactly where they should be intersecting.
Wait, am I trying to find points or am I
Or
trying to?
7.
Because like I have 2 coordinates for 4, 6.
4,
Sorry?
6, yeah.
How's a
There's 2
4,
coordinates.
6?
Yeah, all you need is 2 points, so you can use any 2 coordinates and then you draw a straight line.
Snake then. It's not.
So it looks like
4, 7.
the way I drew it is 4, 6.
Oh.
How? It's 7 though. If you go up 1 from 6, it's 7, and that's what it actually means. Look.
It is.
I drew my odd. You know what? It's a little bit hard to draw my straight lines on the smartboard. You did yours a little bit properly, a little bit more accurately. You get 4, 6. So
Point.
how can I check this?
Plug those numbers in.
Thank you. Right? So this point needs to make each of my equations true. So here, let's work with the black one. Left-hand side, right-hand side. What's the right-hand side? 0. So left-hand side, x is 4, so I get 3 times 4 minus y, which is 6, minus 6. So we get 12 minus 6, which is 0. So that was good for the black equation, the first equation. Blue one. Left-hand side, right-hand side. So now the right-hand side is 0. The equation is 4 times x, which is 4 times 4, minus 2 times y, which is 6, minus 4. So 4 times 4 is 16. Minus 2 times 6 is 12. Minus 4. Oops. There I got 4 minus 4, which is 0. Okay, so now that we got our point, right, we can kind of check. Just by plugging it in, it makes both equations true. Okay, so you could have checked for 7. Probably the first equation you would have saw that you were off. And go back and look at your graph again. Okay.
But on the smart board, it looks exactly at 4, 6.
Again, it's hard for me to draw straight lines on my smartboard. I just knew ahead of time 4, 6. And in fact, I had it over 4, 6, and then I had a stutter right before I let go of my finger and moved it up. Okay, so this is how you solve linear systems by graphing. Here's another one. So I want to do this quickly because I just want to demonstrate the concept. I don't want to take up too much time, right? What I could do is this one. So once you write both the equations down, y is equal to 3x minus 7. So there we already have in slope-intercept form. So here it's going to negative 7 is down here, and my slope is 3. 3, 3, okay. So my line is going to look something like So for the blue one, 6x minus 2y, I'm going to convert that. So I'm going to add 2y to both sides. 6x plus 4 is equal to 2y. I'm going to divide both sides by 2. So I go 3x plus 2 is equal to y, or in other words, y is equal to 3x plus 2. How do you know that already? Good. So they have the same slope. So that's why I convert to y-intercept form. Or slope-intercept form. So I'm just going to graph this anyways. 3x plus 2, so 2. So over here, my slope is 3. So it's 3, 1, 2, 3. Draw my line. And I'll try to extend it the other way. So what do you see about these two lines? You already know. Oh, so where do they intersect? They will never intersect. So where's the point of intersection? It doesn't exist. There is no point of intersection. So this, when you have parallel lines, because they will never intersect, this has no solutions. Okay. So this linear system has no solutions. Okay, questions on that? Parallel lines don't intersect, so we don't have an answer. That's in a nutshell. So here's another one. Y is equal to negative 3x minus 6. So I'll quickly graph this one for you. So negative 6. Slope is negative 3. So you can go up 3 to the left as well. So here's that first line. Okay, so that's the first line. So I'm going to do the same thing on this side. I'm going to isolate for y. Actually, you know what? This one I'm going to do the x-intercept, y-intercept. So the y-intercept, that means x equals 0. How I graph it? No.
How'd you put those?
It doesn't matter. How you graph it, you might want to like, so this was in slope point format, which is use slope. Here, I kind of see that zeros might work out. Give me exact numbers there. So here, if x is equal to 0, 2y plus 12 is equal to 0. So 2y is equal to negative 12. So y is equal to negative 6.
How'd you put those two dots on already? The negative 6, I understand. What's that?
So my slope is negative 3. So I go down 3 to the right, or I could go up 3 into the left. Right? So here's negative 6. The x-intercept. Y is equal to 0. So I get 6x plus 12 is equal to 0. 6x is equal to negative 12, so x is equal to negative 2. So that's the point over here. So I graph that. I'm going to graph that.
It's the same thing.
Whoa.
Is it the same line?
Yeah.
Lineception right there.
Lineception. Okay. You could have saw, I think Aaron already saw that was the same equation. If I converted this to slope-intercept form, right? So I'm going to convert it this second equation to y equals mx plus b. I would have gotten that. Same line. So where's the point of intersection here between these two equations?
Everywhere.
Every
Well,
single.
not everywhere, but everywhere on that line.
Yeah.
Well, it's everywhere. It's, everywhere could be over here, right? So what, question? Almost done here. So for this case, there are infinite solutions. That means every single point on this line makes those equations true because they're the same line. And there's infinite amount of points on the line. So the last two notes. Parallel lines have no solutions. So you need to know this. Parallel lines have no solutions as there's no point of intersection. Voice. Parallel lines have no solutions as there's no point of intersection. So that was like, the whole causes Coolidge and Morgan's muscular gym to begin with. Right? There was no solution to that. There was no break-even point to that. So the second concept is equivalent lines have infinite solutions as they are really the same equation. Any questions on that? Just want to make sure you understand the concepts and what. Don't get freaked out when that happens, right? So for homework, that's your homework.